Okay, so we're given that the time between incoming phone calls, our call center is a random variable with exponential density, and there's a 50% probability of waiting 20 seconds or more between calls. And we asked to find the average wait time between calls. Okay, so what can we extract out of this? First of all, what information do we know? Well, we know that for one thing, that we're given that it's exponential density, and you want to find the average mean time. Okay, so the equation for a probability density function of mean r is 1 over r e to the minus x over r. Okay, where r, well, maybe I should have done this in different color. Okay, well, this is, say, 1 over r times e to the minus x over r. Okay, where r is the mean. Okay, and this is a fixed value for this function, right? Okay, so this is essentially, this is a constant. Okay, and we're also given that the probability that x is greater than or equal to 20 is 0.5. Okay, all right, so we have those two pieces of information. Okay, now how do we move forward? Well, we know that if you have the integral, okay, over some domain, some form interval j, and if the function, the variable x is only defined in this interval, then this is going to be equal to 1. Okay, and similarly, if you want to find, well, if you want to find the probability of a variable taking any value in some domain that we're interested in, we use the same approach, right? So in the same way, this is saying that the probability of j being greater than x. So essentially, this is saying the probability of x being 20. No, geez, 20. So this is a number line. Okay. This is a number line. Okay, this is 20. Okay, and then this is infinity. Okay, so the probability that x is being 20 or greater, so off to infinity, is 0.5. Okay, so j is so j in our case is 20, and this is a closed bracket because it includes 20, and to infinity, which is, okay, open bracket. So that's the interval we're interested in, and we're given this. So what that means is the integral from 20 to infinity of this of p of x, right, of p of x, doing the same color, equals 0.5, right? Oh geez, equals 0.5. Okay, so this value. So, well, okay, I'm just going to say the probability that x is greater than 20, right, which equals 0.5. Okay, so now we just replace this value with our function that we have over here, so that we get the integral from, well, I'm just going to bring it over here so we have more space. So say integral from 20 to infinity of 1 over r e to the minus x over r, okay, equals 0.5. Okay, so now we know r is a constant, so we can treat this as a constant, right? So we can pull this 1 over r outside. So that's 1 over r times the integral from 20 to infinity of e to the minus x over r equals 0.5. Okay, so now we just need to solve this integral, right? So I'm just gonna I'm just gonna take this, okay, take this thing and get over here, and then you're gonna say 1 over r times the integral from 20 to infinity e to the minus x over r dx. Okay, remember it's dx because r is a constant, so we are trying to integrate with respect to x. Okay, that's the variable we're interested in. So how do we go about integrating this? Well, always go for substitution first, see if that works, right? That's my approach. So we see that if we let this be u, okay, and this is 1 over r as a constant, so if we just let this be u and differentiate it, we get so this x goes away, so that might work, right? So let's go ahead and work with that. So let's say let u equals minus x over r, okay, and then remember r is a constant, so du by dx equals minus 1 over r times this goes to 1, so minus 1 over r, and du equals, so it's gonna move these things around, so du equals minus 1 over r dx, and then multiply both sides by minus 1 and then an r, so we get minus r du equals dx. Okay, and now we have parts that we need to substitute, right? So we have what u is, right, this, and we have what dx is, which is that, right? So we can take those two parts and we can say the integral, so 1 over r time from the integral of from 20 to infinity of e to the u, right, and then minus r, so minus r du. Okay, so this is a constant. Now we can pull this minus r out, so this is going to be minus r over r, so this is going to be minus 1 times the integral from 20 to infinity of e to the u du, and that's, we know how to do that. That's just going to be e to the u, right? So that's just minus e to the u from 20 to infinity, but of course we can't just plug in these two values for u because these are values for x, so we gotta bring x back into this, so this is equal to minus e to the minus x over r from 20 to infinity. Okay, all right, so now we just need to solve this. So it's gonna bring this up here. Okay, so essentially, so now first we evaluated at the upper bound. So what is the limit of this function as x goes to infinity? Well, for the upper bound, it's just the limit as x approaches infinity of minus e to the minus x over r, which is equal to the limit as x approaches infinity to minus 1 over e to the x over r, right? And as x goes to infinity, this goes to 0 because x infinity divided by some constant is still infinity, and this gets smaller and smaller, and this goes to 0. Okay, so that's the upper bound. And then next you need to evaluate the lower bound. So minus e to the minus x over r evaluated at (20) and infinity is the upper bound, which is 0 minus 1 over e to the 20 over r. Okay, so these two minus signs cancel out, and we get 1 over e to the 20 over r. Okay, and all this, we know that this whole thing, this integral, is equal to 0.5, right? So we have that 1 over e to the 20 over r equals 0.5, right? And then all we have to do is simply solve this value for r. Okay, so if we do that, we can just, we can do the algebra. So this is 1 over 0.5 equals e to the 20 over r. So this becomes 2. So 2 equals e to the 20 over r. And then if you take the natural log of both sides, ln of 2 equals 20 over r. Then r equals 20 over ln of 2, which equals 28.85. Okay, and that is r, and that is our mean time, average wait time between calls. Okay.